welcome you all to our today's presentation. I hope you can hear me.
Yes, we can hear you.
Thank you so much. So, welcome you all for this presentation. It's a solar design presentation where we are going to focus on cable sizing. So, I welcome you all for the presentation. So, my name is Engineer Ondora Mogere Dalton. I am a technical engineer, a specialist in solar technology. So with me, I have Engineer Aziz, who has a specialist in solar design. Is going to take us through the training of today. So, Engineer Aziz, you can introduce yourself and you take us through the designing process. Yeah, thank you.
Thank you, Mr. Andora. First of all, I will welcome all of you in this free webinar. My name is Azizul Hassan. Basically, I'm from Pakistan, and I have total 6 years of experience in the solar designing field. I have worked on different level projects, like in the uh, residential, commercial, industrial level, and also on the power plant sites. So, in this webinar, we will discuss about the cable sizing. In the previous webinar, most of the people have joined us on the previous webinar on the last Sunday. We have talked about on the cable the layout in the AutoCAD PVSys report, and then the SketchUp software. So for the PVSys, we have to give the different voltage and losses to simulate our mm, simulation report. So for that, one important factor is the cable sizing. And in this webinar, we will discuss about the cable sizings, basic of the cable sizing and how. So now I'm sharing my screen. Definitely uh, ensure the safety of the equipment, because if the cable is not properly sized, if they heat up and burn due to the some reason, like the heating effect of the other cable which is installed near to the cables, or the other factors like the grounding factors, there are the different factors which will impact the increase the temperature of the cables, and definitely after some time they will burn. And if the cable is burned, they will impact the insurance of the and the safety of the equipment is no longer remains same. So that's why the cable is very important factor. The other one is the compliance with the IC standard. IC standard basically the international standards. In the case of the power plant, before the solar is not in familiar, and like in the peak point. Now the solar is on the peak point, and the IC international standard the community has introduced the value for the voltage drop on the DC size and the AC size for the solar plant also. But in the previous version of the IC, the standard value they give only for the power plant in the generation area different. So that's why the compliance of the cable for with the IC standard is very important factors. So in the IC standard, they gave us the permitted value of the voltage drop, the rated current, and the ampacity of the cables. On that basis, we will select our cables. But mostly we will use the manufacturer values, because when we are using some manufactured cables, they will give us these some value of the capacity of the cables and different derating factor. So that's why we have to compliance with the standards of the IC standards. The other important factor is the reduced O&M cost. When the cable will properly size, and they will not damage due to the heating and many other reasons. Uh, and they will not affect the equipment due to the cables. Due to that, the operation and maintenance cost of the company reduced, because when the EPC company has installed the power plant in the power plant, they sign 2 to 3 year of the operation and maintenance of the plants. So after that, they will hand over to the client for the O&M issue. When after that, in 2 to 3 year, they are in the EPC responsibility. If any issue come, they will have to rectify this issue due to the cables. When any equipment damage or burn, this will impact the O&M cost of the EPC company. So that's why we have to size the cables are in the proper manners. The other point is protects equipments. When the cables are properly sized and they will not burn due to the many reasons, this will definitely impact the equipment protection also. So the other point is the improved system reliability and performance. When the cable is not properly sized, there are the multiple cables used in the power plants. I will explain in the next slide. So the voltage drop impact a lot in the performance of the power plants. When the voltage drop on the DC cables and the AC cables is on the higher side, they will definitely impact the performance ratio of the solar power plants. Because when the EPC companies are signing the project, they will sign some performance ratio of the power plant for the whole 25 year or 30 years. They will sign, they will meet this performance ratio of the power plant for these days, which is basically decided on the basis of the PVCs reports. In previous webinar, I have discussed about the PVC report. So the performance ratio is very important factor for the power plant designing. So the cable is very important in that way. Now move on to the next slide, which is the cable types used in the solar power plant. First is the DC string cables. Basically, DC string cable is the small cables which carry the power from the solar panel to this is very important factor, and this is very important cables which when we are sizing the power plant, we have to size the DC string cables also. The other one is the LVDC cables, which is connecting the combiner boxes to the central inverter. There are basically the two kind of inverters. We have previous in the previous webinar we have explained these inverters, central and string inverter. Central inverter basically have the low number of the MPPT trackers in the central inverter. So we have the limitation of the connection of the number of the string on the central inverter. And the central inverter power is on the higher side, like in the megawatt scale, like 1 megawatt and 1.1 megawatt and 1.3 megawatt. So we have to connect the DC strings and DC panel in the huge number of in huge numbers. So that's why when we are connecting the number of strings, the combiner central inverter, we can't connect maximum up to to 5 or 6 strings. So that's why we have to use the combiner boxes in between the string cables and between the central inverter. Basically, strings are connected at the combiner boxes level, like 15 or 14 or 18 and 20. And then we gave the one cable go out from the combiner boxes and connect it on the central inverter. This cable basically is the LVDC cables, which is on the higher mm values. like in the 185 mm square, 150 mm square, 240, 300, and 400, like in that way. But the string cables are in the 4 mm, 6 mm, maximum by 10 mm. It is mostly it is used by 6 mm, but due to the different reason, we have to use the 10 mm cables. The third one is the LVAC cables. Basically, LVAC cables is connecting the the LVAC cables is basically the string inverter which convert the DC to the AC, and then we have to the transfer the AC power to the LV switchgear levels. So we have to use the LVAC cables, and then MVAC cables. MVAC basically we have to use between the MV switchgear of the subs of the MV stations to connect with the substation level, like at the 33 kV switchgear in the substation levels. So we have to use the MV AC cable from the MV switchgear, from the AC cable, the AC power of the inverter from the 0.8 kV or to the we have to step up through the MV transformer at the 33 levels, and then we have to transfer this power of 33 kV to the substation level. So for that purpose, we use the MVAC cables. And the last one is the HVAC cables. HVAC cable basically is the cables which are used for the transformer of the power from the substation to the POC levels. POC is basically the power of connection, where we are using connecting our solar plant to the existing power plant of the a client. When we are in the small level, for the residential or for the commercial level, we have to connect our solar plant to the main power plant level. We have to connect our main solar plant to the POC level. So the cable used for that purpose is called the HVAC cables. Now move on to next slide, which is very important, and the main key input we require for the cable sizing. One is the power, the other one is the voltage, the third one is the current, fourth one is the length, and the fifth one, which is missing in the slide, is the power factors. So the power basically we are transferring power to the different levels. So this power is used for the cables, and on that power level we use the voltage level where we are connecting our cables. Like in the string inverter level, we are using the 0.8 kV voltage level. We are using 800 volts. For the DC strings, we have to combine our number of strings and then multiply number of panel in the one string and multiply with the uh, operating voltage of the power panel, solar panels. And the other one is the current. Current is basically for the DC level we use the string current, and for the AC we use the current output of the inverter. From For the MVAC cable we use the output current of the MV switchgear, and for the HV we use the current used for the from the out from the main substation transformer, like the 220 kV voltage level. They give us the current value. On that basis we will design our cable sizing. And the other one is the length of the cable. The length of the cable is very important. Basically, length of the cable is used for the voltage drop calculation levels. So when the cable length is higher on the higher side, the voltage drop is on the higher side. So that's why we have to maintain the voltage drop in the permissible limits. We use the length. If the cable length is on the higher side, we increase the size of the cables, the area of the cables, like square, where we are using 185 square cables, and the voltage drop is 2%. But we have the limit of the 1.5, then we use the 240 square cables. Voltage drop, I have already explained that for the cables, the allowable voltage drop for the DC string is in between 1 to 1.5%. For the AC cables, basically IC standard allow us the 3 to 4%. But due to the different uh, limitation of the different client, there are the different client which are on the strictness sides, and they don't allow us the voltage drop level for the AC cables from the 1 to 1.5% maximum they allow us. That's why to give the performance ratio on the higher side. The other input is the ambient condition. Ambient condition is basically the environment where we are installing our cables, laying our cables. Like in case of the overground cables, where we are installing our cables in the cable trays direct to the walls, open on the ground, and the other criteria underground cables. We are using the laying our cable in the direct buried case. Direct buried, basically we don't use any medium between ground and cables. And the other one is the duct bank case, and the cases where we are install our cables in the ducts. So the ambient condition is very important, and we have to analyze our cable sizing on that basis. The other factor are the derating factor. Basically, derating factor very important factors. When the manufacturer or IC standard gave us the ampacity of the cables. Ampacity is basically the cable maximum current value which the cable has can draw while running. So that when they give us the cable ampacity, they give us the ampacity of the cable on the different factors, like what is the value of the soil thermal resistivity, what is the value of the temperature of the ground, depth of the cables laying. So on that basis, they give us the cable ampacity. But for our cases, there are many chances that when the cable are installed in the ground and the overground, they will not follow the same factors which have considered by the manufacturer. So for that, we have to apply the derating factors to derate the current. And when the current is derated through the derating factor values, we will compare with our load current. On that basis, we will define our cable size. Cable derated current is basically the ampacity of the cable multiply with the derating factor. The derating factor which come out from the multiply of the different values give from the manufacturer or the IC standard. So the main and for the MV cable sizing, we have to care about for the LV sizing, like the 33 levels down size for the inverter and DC strings. We don't care about the short circuit value of the cables because it is very on the lower sides. For the MV cables and HV cable, we have to consider about the short circuit value of the cables. Manufacturer has given us the short circuit value of the current which can apply to the cables, and cable has bear this short circuit. On that basis, we will calculate our short circuit value of the power plant and then apply on the cables. If the cable is satisfying this criteria, we will consider the size of that cables. And then the installation medium, I have already discussed about the installation medium on which are the cable installed in the overground in the cable tray and direct to the walls, and the underground cables in the duct bank and the direct buried case. Then we move on to the next slides, which is the common mistake we are doing while sizing of the cables. Ignoring the voltage drops. Voltage drop is, I have already discussed all of you about the voltage drops. And if we ignore the voltage drop, it will impact our the performance ratio. Then the next is the not applying derating factors. If any designer don't apply the derating factor of the cables, it is definitely impact the size of the cables and the performance of the power plant and the equipment safety. Due to that, we have to apply the proper derating factor on the ampacity of the cables in correct ambient temperatures. If the cable is installed in the 30 degree centigrade, but the cable manufacturer give us the ampacity of the cable on the 20 degree centigrade, and we don't care about that temperature, and we have installed our cables, then this will definitely affect the rating of the insulation of the cables, and due to that they will burn the cables. Then the fourth one is the overloaded cable tray. While case of the cable tray installation, where we are installing our cables in the cable tray over ground, mostly in the solar power plant, we are using the cable underground. But there are some cases occur in the power plant. We can't dig the cable trenches. Like in my cases, we are uh, now we are designing a power plant of the 72 megawatt, in which the client has given the restriction of the we don't they don't allow us to dig the cable trenches. For even in the case of the earthing, we don't dig the there are the different reason due to the multiple factors. So we have to install the cables on the cable tray. The IEC standard give us the value that the cable tray should be uh, fair enough free while installing the cables. Like the 30 to 40% cables tray will be spare, and if the cable tray, um, many vendors and many EPC contractor, which they have their cost limitation, they will overload the cable tray. Due to that, the cable will burn due to the heating of the different other cables impacts. The fifth one is the no proper thermal assessment. Basically, thermal assessment is the assessment of the temperature of the cables due to due to the ground, due to the nearby cables. The thermal assessment is performed through different softwares. We check the temperature of the cables. When we give the value of the load current, the software tell us that how much the temperature of the cables at that time. And the manufacturer give us the, in case of the XLP, they give us the maximum temperature of 90 degree. In case of the PVC cables, they give us the 70 degree. So we have to design the cables in that limit. In case of if we perform the thermal assessment, and the software tell us that the temperature of the cables is rising from the 90 degree above, like in 95, 94, the cable size is not proper. So we have to increase our cable size. So the thermal assessment is very important factor for the power plant cable sizing. And the other one is the incorrect grouping factor. Basically, grouping factor is the how much number of the circuit installed in the same trench. So these are the grouping factors, and the manufacturer give us the different value of the grouping factor. Like for the sixth number of the circuit, they give us the 0.7 derating factor. For the four, they will give us the 0.8 factor. So this is very important factors. We can use different tools for the sizing of the cables. One is the thermal assessment is very important. For that, we have to use the softwares. One is the ETAP and one is the SIMCAP. Basically, ETAP has, there are the different limitation. They give us the thermal assessment for the direct buried case, and for the cable installed in the duct bank or ducts. But the SIMCAP is the software which is very important and paid software, which is not we can give the crack. We have to purchase this software, which is basically designed for the cabling of the power plants. In that they give us different opportunity, like the cables installed in the direct buried case, trenches, overground, in the tunnels, in the water. They gave us all the designing. So we have to use this software for the thermal assessment. and we can't ignore this thermal assessment. I can I can't every designer to recommend that uh, uh, perform the thermal assessment must. And then the other one is the excel sheet. Excel sheet basically used for the manual calculation of the cables, in which we apply the derating factors and derate the ampacity of the cables, and then we compare through the load of the cables and calculate the voltage drops through the formula of the voltage drop level. And the other one is the PVK software, which I have already discussed in the previous webinar regarding the PVKs. They give us the layout designing, and in that we design and we calculate the distance and length of the cables used for the power plants. In the previous webinar, we have discussed about the different software like the AutoCAD, SketchUp, PVSys, and past experience I have shown to all of you, and the practical work presentation. AutoCAD basically used for the 2D layouts. SketchUp is used for the 3D modeling. PVSys is the simulation for the generation reports. If anyone have missed this webinar, you can see the recording of the previous webinar. And the previous webinar we have tell us about the project workflow, uh, from the start of the site visit to the designing, then the client approval, procurement, installation, testing, commissioning, as built work. These are the overall power plant designing, and from the start of the plant, then designing. Site visit very important. We have to see the shading objects, the side of the situation, and then we design our power plant. In that, we design the renewable part like the panels and the cabling and the PVC report and the civil work all over, and then we give the client approval for that drawings from the client. On that basis, we start our procurement. Then on that procurement, we start our installation, and after the installation of the overall plant, we will perform the testing and commissioning. And in case of the system installation, there are the multiple factors that the system designing and system installation. There are the multiple changes in the installation phase due to the multiple reason. While the trenches, we have lay the trenches in some area, but in on the actual side, we have to divert our route. Then the as-built work is which we will incorporate all these changes in the design work, and then we will submit to the client for the O&M purposes. And then in the overall power plants, we have to avoid the different mistakes while the sizing and basically we have to avoid the mistake in case of the sizing and the system designing, the oversizing undersizing of system. We can't do underside and oversize, because if the go oversize, it will impact our cost. If we go underside, this will impact our system performance. And then ignoring the shading and orientation. Basically, for the solar power plant, shading is very important. We have to give the panels some time which is shadow free, like in between 9 a.m. to the 3 p.m., which is the peak hours of the power plant energy, solar energy. So we give the shadow free of the power plants. And the orientation, at what angle we are, the power panels are placed. For the tractor, they will rotate in the east-west direction. For the fixed orientation, very important factors. uh, Proper cable sizing, improper cable sizing, and protection design. I have already discussed about the cable sizing, which is very important. Protections, very important factors in the sizing of the, like the fuse sizing, cables, breaker sizing. So there are multiple protection levels. So we have to design proper protections. Improper cable length, if the cable sizing, we will not get the proper cable length, then definitely impact the voltage drop and everything. Raw equipment coordinations. Uh, uh, which is a very important coordinates wrong if we install give the coordinate of the equipment while the sizing of designing of the project, and in installation phase it will install on different location. This will impact the length of the cables, and many other things. So we have to give the proper coordinate of the system where the system is installing in actual phases. So now I will shift uh, to the Mr. Andorra to explain regarding our paid training, which is coming up in the August from the 4th to 22, and this will very important training, and we will give the deeply like in the cable sizing. I will explain all of you regarding the factors, but in the paid training I will properly give the sizing of the cables through the Excel and the proper to the thermal assessment. I will recommend all of you to join this training. So, Mr. Andorra, now move on, hand over to you this training.
Thank you so much, Aziz, for that wonderful presentation. So for the oncoming training, we're having it from the on August from 4th to 22nd of August. We are going to focus on PVCs and SketchUp. And the cost for the training is $60. And also for $60. So I've shared the link for the application in the chat box. Maybe if you're interested to learn more on now how to simulate using PVC, SketchUp, and also AutoCAD, I call upon you so that you can join. So I think maybe Engineer Aziz, maybe you can have like some presentation on the same on the softwares, what they are expected to learn, so that at least somebody can make a decision on the same. So as you are preparing on the same, actually you are going to give access to the softwares, that is PVC, SketchUp, and AutoCAD. We are going to show you how to get the softwares. So yeah, it will be a 3 weeks training in the evening hours. Maybe if you are in the Eastern time, that is 7 p.m. to 8 p.m. And if you are in the Pakistan time, that is 9 to 10 p.m. So you can prepare on the same. And also maybe you're outside from Eastern African time and also Pakistan time, you can just convert the time to their local time. So Engineer Aziz, are you able to give us like a presentation on the softwares?
Uh, um, for the softwares,
Yeah, for the remaining
okay.
minutes. So, okay, there's a question as you are preparing also. There's a question in the chat box that asks if the distance from the panel strings to the inverter room is around 200 meters, then how should you should we select the wire size for the string? Should it be 4, 5, 10, or 5, 4, 10, or 5 squared? If the distance from
Uh,
the panels to the inverter room is 200 meters.
Mr. Ondora, I think on the next Sunday we will arrange another free webinar for our audience. In
Okay.
that webinar, we will discuss about the PVC, AutoCAD and SketchUp.
Mhm.
Now I think it's better we will get the question from the our audience.
Okay.
I think it's better. Um,
Okay.
because in the previous webinar we have discussed about the different softwares, but
Okay.
in the cable sizing very important for all of the designers. So in that I have discussed about the solar cable sizing. In the next we will discuss about the overall overview of the cabling and everything. So I think everyone have to join us on the next Sunday regarding this free webinar. We are giving the free webinar to our audience because most of the people want that they give us the don't know about the basic of the solar system. When you join our paid training, you already have some knowledge about the basic of the systems. So then you will get more deeply the systems knowledge and designing of the overall system. I think anyone have the questions? Um,
Yes, any question maybe?
Hello, engineer. I don't know, maybe you can hear me.
Yes, we can hear
I
you.
so much appreciate this, and this is my first time of joining you, and I hope I will try as much as possible not to miss this webinar. And I want to use this opportunity to thank you and to appreciate you for your time. I know it's not easy, and in the process of you mentioning those tools to be used, I'm able to record 3 to 4, and I missed out the other ones because I'm writing as the way you are presenting, and it does not take much time for you to take it off. I don't know, maybe that page can be displayed so that I can finish writing the remaining ones for the tools to be used. For example, the Excel spreadsheet for manual calculation, ETAP, AutoCAD, and the rest. I'm unable to write it out, so at least I can start doing something on my own, depending on when the design class will be taking place. So it will be easier for me to grab whatever you're going to say at that class. It's just like me trying to look up into the software before the actual training begins. Thank you.
Yes, Engineer Aziz, you have heard the question.
Uh, yes, while the writing of when you are writing, I think Mr. Andorra, we will share the PPT with in the group.
Mhm.
They will give and the previous PPT with our audience, and on that basis they will give us the information. And if you have any question regarding the PPT and software for the training, we will give us the software installation method and for the free. But I have already discussed about the PV case, which is the paid one. So I think Mr. Andorra, we will share. It's
Yeah, okay, okay, it's okay. There's another hand from Emmanuel. Emmanuel, you can answer, ask your question.
Okay, good evening to you, Mr. Aziz and Mr. Ondora.
Good
Okay, so
evening.
it hasn't been long that I joined this meeting. I just saw it on LinkedIn and then I decided to join. So I don't know if there is any way we can get the recording of the meeting because I wasn't here. Like it hasn't. I don't think I spent up to 5 minutes
Yeah,
so
okay.
far.
Yeah, the recording is there, and also we are live at LinkedIn. So maybe if you will go to the page of Torchbearer Institute of Technology, you'll be able to get the
Okay.
recording. So we are live in at LinkedIn.
All right, no problem. Thank you so much.
Yeah, thank you. Yeah, so maybe as to finish, maybe I welcome you all for the paid training. Is $60. We are going to start in the month of August 4th to 22nd. So ensure you register for the paid training. I've shared again the link in the chat box. So ensure you register and you make your payment early. So next Sunday also we are going to have another training. I think next Sunday will be deep on the same for the softwares as we prepare for the further training. So I've shared the link in the chat box so you can make the registration. And also don't forget to follow us in LinkedIn as Ondora Mogere Dalton. And also don't forget to follow Torchbearer Institute of Technology and also Engineer Aziz and AHA Creative Energy Creatives. So I think Engineer Aziz, we are going to finish our presentation at this moment.
okay. If you have any question, we can ask. Then if don't, then we will close our session.
Okay. So if there's any question, maybe concerning the oncoming trainings or any other question, for the remaining 13 minutes, so that we can finish our session.
I think, Mr. Andora,
Yes.
we will close our webinar.
Okay.
Thank you, everyone, for joining this webinar. I think it's very helpful, all of you, for this.
Yeah.
Yes,
Mhm.
Kazim, Habib, I think they have some question.
Yeah. How can we access the cable sizing software? It will be provided during for the paid training. So
Yes, yes.
yeah, it will be provided for the paid training. How to access
Uh,
the software and all that will give it more information during the paid training.
yes, there are some question from the Shazad. There
Okay.
is one. Mr. Shazad, basically, distance is 200 meter. You are recommended. You are giving us, but it will depend on the current of the panels and the string of the current. If the panel is high on the higher side, like the 680 or 700, then it will definitely the cable size is different. If the current is for the 500 and 400 watt panel, the size is different. So in that way we can't decide the cables. We have to perform the calculation to proper manner, like the proper formula. Then we will decide which size is suitable.
Okay. Thank you so much, India, Aziz. So I think
Thank
we
you,
can.
everyone.
Yeah. Thank you so much. Thank you so much, everyone, and have a wonderful evening. Have a wonderful night, yeah, and others a wonderful morning. So thank you so much. See you next Sunday, and also prepare for the paid training. Thank you so much.
Thank you, everyone.